Alright, today I'd like to talk a little bit about how bone repairs itself. So, today we're talking about bone repair. And let's say you have a bone, it could be any long bone, your femur, your humerus, and let's say there was a fracture right down the middle, right down the diaphysis of this bone. The first thing that's going to happen is, obviously those nerves are going to be stimulated. You can feel a whole lot of pain, but you're going to have all these blood vessels that are inside the bone itself and inside all this ostia and all that bone tissue that's going to bleed. Okay, and you're going to get a lot of loss of blood, and the first thing that's going to happen is that blood's going to clot. All these platelets are going to come in and they're going to clot this bone, clot that blood, and that's going to create this big, huge hematoma. So the first step of repair is the hematoma, and that's a big mass of clotted blood and just bone tissue that's been broken. Then the next step that needs to happen is that, let's draw another step right over here. So we have this fractured bone. The next thing that happens is that fibroblasts that originated from the periosteum and the endosteum of this bone. So remember, we have this layer of connective tissue all around the outside of this bone, that's the periosteum. And on the inside of the medullary cavity, that's the endosteum. And it contains all different types of osteogenic cells and blood vessels, but it also contains fibroblasts. And those fibroblasts are going to start dividing, and they're going to start secreting their collagen. And at the same time, you're going to have macrophages that come through and they eat and consume and clean up all the mess of all this debris. So you have macrophages that are cleaning up all the mess of the hematoma, all that clotted blood, all that leftover debris of the broken bone. And at the same time, you have fibroblasts that are secreting collagen and making cartilage. And that's going to form the second step of the repair, which is called the soft callus. Right. Then, after that happens, we've got our soft callus made by cartilage. And if you remember, just like growth in a long bone along the epiphyseal plate, that cartilage lays down a framework for osteoblasts to come in and start making bone tissue. So we have this soft callus. Now we have osteoblasts that come in, move into that cartilage. The cartilage enlarges, those cartilage cells enlarge, they die, they leave little spaces. The osteoblasts can come in and they can start reworking that cartilage into bone, right? And this forms the third step, which is the hard callus. Okay? But if you notice, there's a little line. It doesn't look like a normal non-injured bone. You've got a little, line here. You've got some areas that aren't just quite as smooth and as strong as they should be. And that brings us to the fourth step. That's when osteoclasts and osteoblasts just start remodeling this area. Osteoclasts are eating this area, dissolving it. Osteoblasts are making more tissue. And that allows us to repair the bone almost to its original state. There might be a little enlargement around the original site of the break, but it's going to be nice and strong, and that's due to bone remodeling.